All right, guys, in lesson 4.7, our focus lesson today, our I can statement is to generalize properties using variables and explore applications of the distributive property. So we're going to look a little more intensively at the distributive property. Okay, to generalize these properties, that means we want to be able to apply them to any number. So that's when we come in using variables like A, B, or C to represent any number we would plug in there. Okay, so for an example here, on question 1, we're going to use this distributive property to write two equivalent expressions for the area of the rectangle. Okay, so to start out here, finding the area, we can break it into two parts and add them together, or we could find the area of the whole thing. And using that distributive property can help us do that. So if I, for example, start with, if I add B plus C, that'll give me this whole, the length here. So if I take B plus C, I want to put that in parentheses because we know with the distributive property we need that, but we want this to be together and be all one thing. Okay, so that keeps it together. And I know to find the area of the rectangle, we just take length times width. Okay, length times width is area. So I already have the length, I just need to take it times the width. So in algebra, I don't need to use a times sign or a multiplying sign. I can say this is A times whatever B plus C is. So really, it's just this width times this length. Okay, so that is multiplied. Again, you could put a multiplying sign in there if you wanted. Okay, so that's one way to do it. Again, that generalized it because now A can be any length I want it to be. If A was 7, I'd put in a 7 here. If A was 8, I'd put in an 8 here. It doesn't matter. Okay, so it just depends on the situation and that can change. But now it's generalized that this would find the area of any sized rectangle. All right, now to use the distributive property, we know now is to distribute the A through the parentheses. I have to take A times the B. So that A times B, and again, we don't need a multiplying sign, so A times B is just AB plus, and we must also take the A times the C. So A times C. And now I have generalized this to work. We know this would work for any numbers now, and we know this is the same as this because A times B would just get me the area of that part, and A times C would get me the area of the smaller rectangle there. And you add them together, you'd get that total area. So this is what it means by generalizing the formula. Okay, don't use numbers, use these variables, and then I could plug numbers in, and this formula would find the area for me. Okay, another quick little example here on number 2. If I've got to generalize this, a simple example, 3 plus 5 equals 5 plus 3. All right, I know that's the commutative property of addition. I know all they did was flip them. So to generalize that, 3 we could call A, whatever variable we wanted, plus B would equal, and they just flipped them, so I would flip them, and the B plus A is flipped, and they're the same thing, and that generalized this property for me, and I could plug any numbers in there now. I wouldn't have had to use an A and a B. I can use any variables I want. A lot of times you'll see X and Y, but I chose A and B, but it could be any letter you would like to represent, to generalize this property. Same thing over here. 3 times 5, I can just call that A times B. I'll use a times sign this time. Equals 5 times 3, so they just flipped them. So it would be B times A. And again, I just generalized it. And that's for the commutative property. Okay, and on your sample practice problem slides, you guys will be generalizing some other properties as well, getting them and using variables to do that. Okay. Another example we're going to look at here, going to be flipping over here to another page. Again, I'll pause that video back when we're watching it if you need to, or you guys can go back and pause it if you're watching from home. Another type sample question here. We're going to use these general equations properties and identify whether these are true or false, and then list that property. We got to know these properties. So again, we'll just start with a very simple one. 3 plus 4 equals 4 plus 3. We know that's the commutative property again. So that is true. We know in this case they both equal 7. And the property, I would just write commutative property. Okay. So you're going to be looking at other properties and to make sure you know the different properties and are able to identify them as well. So we've got to know those properties. So again, make sure you have this stuff written down. All right, another example on this page. Go down here and look at 5. It says for each equation, we're going to circleize the generalized form of the property that shows it's true. All right, so we're just going to look at question, a little bit tougher here, but on question A, we've got 4 times the quantity 5 plus 3 equals 5 plus 3, the quantity of that, times 4. And what you need to see, what's a little more difficult here is, guys, this is simply the commutative property. This goes all together. So we could look at this as like A times B, because 5 plus 3 goes together. So if I flip that, it just became B times A, because all this is the same thing. So really, they just flipped. So this is the property that generalizes it. It's just a little bit more complex. Okay, all it is the commutative property with parentheses included in there, but they're still just flipping. So there can be little variations that make it a little tougher to understand which property is going on in which situation. Okay, so you'll be taking a look at some of these things. And one more thing to look at here today. All right, so I want you to look right up here. All right, on number 1 up here, we're going to try to figure out how we can use this distributive property a little more to help us with normal problems. So if you look, for example, at 82 times 99, normally I'd do that and I'd line it up like this, right? I'd take 82 times 99 and we'd do our double-digit multiplication, okay, which is fine. But the distributive property can help us. So there's an example up here. I'm just going to go explain it by doing question A here. What if I change 99 to something to help me where I can do things mentally and maybe solve it a little easier? So could I change this problem, since this is close to 100, is what I'm seeing here, could I change this to 82 times, and then parentheses, could 99 be the same as 100 minus 1? That's still 99, right? So 82 times this is 99. But now let's use this distributive property. We can do a lot of it mentally, and it might be a little easier for us. I could take the 82 times the 100, which equals 8,200, minus, now I've got to take the 82 times the 1, which is 82. So simply to solve this problem, I can just take 8,200 minus 82. And if you do that, and you might have to go off to the side if you can't do that mentally and subtract it, but you'd get 8,118. And I didn't have to do any of that double-digit multiplication stuff because I could do a lot of it mentally. All right, so that distributive property, how can I apply this and use this to maybe help make my math life a little bit more simple sometimes? Could I use it if things are close to 100 and things you can do mentally to make them a little bit easier for yourself? Okay. All right, one more example here today. This one's kind of tough for a lot of kids, but again, we're going to try and look and study these and see if we can use this distributive property. And I kind of think of it as like you're undoing the distributive property. Okay, if I can find a common factor, a common fact in these, I can use the distributive property to solve this instead of adding for like 42 plus 28, even though that's pretty simple to do and you can do it pretty quickly. But trying to think a little more deeply about that distributive property. So I know 42 and 28 can both divide by 7. I know 7's a common factor. Okay, so if I look at this here, if I thought about 42, I know that's 7 times 6. So I'm going to put that together. That's 42. Plus 28 is 4 times 7. Okay, so this is still 42 plus 28. But if I'm thinking the distributive property, this is like it's already been distributed through. So I could undo and pull out a common factor. See how these both have a multiply by 7 in them? So if I divide by 7 or pull out a 7, I can pull out a 7 there, which means I'm dividing it out, and I'm left with just 6 plus 4. Because I'm pulling that 7 out, like I'm dividing it out. And I'm left with 6 plus 4. So I actually could solve this problem like this, and just now solve it using PEMDAS. 6 plus 4 is 10, and 10 times 7 equals 70. Okay, so my answer of 42 plus 28 is 70. And that's kind of a more advanced way to look at it. Another way I kind of look at this, I'm going to rewrite it up here. If I just know I'm dividing by 7, I can just write divide by 7 up here. and divide them both by 7. So that means pull it out, okay? And if I divide by 7, 42 divided by 7 is 6, plus 28 divided by 7 is 4. See how it still gets that form that I had it? And how do I know this is the distributive property? Well, distribute it back through. If I take 7 times everything in here, what's 7 times 6? Well, that's 42. Plus 7 times 4 is 28. So this is just 42 plus 28. So there's some ways to deepen our understanding. As you get older, you're going to have to learn to pull out some common factors quite often to help get you in things different forms, to help you solve some things with algebra. So this is kind of just the start of really deeply looking at that distributive property.